Okay, here's a solution for the mock exam for trig functions problems. Let f of x equal, and then they give us the standard function for cosine. Part of the graph of y equals f of t is given below. Okay, so this is the maximum and this is the minimum. I think they're going to tell us exactly how tall those are. When t equals 3, there is a maximum value of 29. So this one is 29 and at m. And so the point m is at the coordinates 3, 29. And then it says at t equals 9, there's a minimum value of 15. So 9, 15. Okay, find the value of a. So remember that a is the amplitude. And the amplitude, you can find like the maximum minus the minimum. And then you could divide that by 2. So that would be 29 minus 15, which would be equal to 14. And then you take 14 and divide it by 2. And that is equal to 7, which is the value for a. So if it's 7, then the mean line, the line that goes through the middle of everything, is at the value y equals 15 plus 7, which is 22. It's right in the middle of 29 and 15. Okay? So let's see what else they ask. Show that b equals pi over 6. Okay, so b is related to the period. And the way it's related to the period is b equals 2 pi over the period. And let's see if we can see what the period is here. Well, if we had two maximums, for example, if we had it like this, then we could say, oh, the period is the distance between the two maximums. Since we don't have that, what we could say is, well, the period is the distance between the maximum and the minimum, so it would be like this, times 2. So how about if we do that, because we do have that. Let's see, the maximum is at t equals 3, the minimum is at t equals 9, so that would be 6, right? 9 minus 3 is 6, right? And so that's half the period. Half the period. So if we want the full period is equal to 12. Okay? And, oops, I'm writing this in the wrong place. Thank goodness for technology. Okay? And so we know that p is 12, so 2 pi over 12 is equal to pi over 6, and that's our answer for b. Okay, so, oh, what do you know? All right. Find the value for d. Okay, remember d is the vertical translation. So let's see. The center line, or the mean line for this function is at 22. Originally is at 0. So the translation is 22, right? So d is equal to 22. Write down a value for c. Okay, now c, this is the trickiest one. C is a translation in the horizontal direction. And we can see here that originally the cosine function should start at the maximum value, and then it goes down to the minimum value, and then it comes back up to the maximum value again. So the original function, or the function that has no horizontal shift, looks kind of like that, okay? So then we say, okay, it is horizontal shifted to the right, from what it looks like, right? How much is it horizontal shifted? Well, let's see. The easiest point to find, I think, is the maximum point. We know that the maximum point originally is at t equals 0. and now it's set t equals 3. So it looks like everything is shifted over by 3 units. So let's say that c is equal to 3. And it says a value for c because there are other possible values. For example, could be 15, like instead of, you could say that, hey, instead of shifting it over 3, you could shift it over 15, 12 plus 3, for example. So there's a lot of different values, but the smallest one is 3. The transformation p is given by a horizontal stretch of a scale factor of 1/2. Okay, and now we're talking about a different transformation than the one we've already analyzed. Okay, so this is another transformation called p. It's given by a horizontal stretch of a factor of 1/2. So a horizontal stretch, that would be a CB transformation, followed by a translation of 3 and -10. So 3 is an x translation, -10 is a y translation, so this would be equivalent to a c and a d translation. Okay. Okay, and so let's see if we can draw this. First of all, we're going to translate it. First we're going to do a horizontal stretch by scale factor 1/2. Okay, and so we're talking about originally, like this function here, right? Okay, so let's do a horizontal stretch. And where does it intersect the y-axis here? It intersects the y-axis. Let's see, the period is 12, and the horizontal shift is 3. So actually, it intersects it exactly there at the mean line. Okay, because this is 1/4 of the period here. Okay. No, back to what they were asking. I already forgot what they were asking. Okay, so first it's going to be a horizontal stretch scale factor of 1/2. So right now, like one period here would be it would be 0 to let's see, 12, right? And we're going to do a horizontal stretch, a factor 1/2. So it's actually going to get smaller, and the new width is going to be 6. Okay, and what it's going to look like is kind of like this. It's going to be a small sine wave like that. Okay, and then the other thing that happens is it says it does a translation of 3 and -10. So in the x direction, it's going to go up by 3, and then in the x direction, it's going to go to the right by 3. Okay, it's going to go to the right by 3, so it's actually going to go to 9. Yeah, and then it's going to go down by -10, down by -10. So it'll be like go from 22 to about 12. Okay, and then the thing will kind of look like that. Okay, and then it says, okay, what happens to the point M? So the point M, when it gets a horizontal smash, the point M ends up here, okay? And originally point M is 3, 29. This new point here is a horizontal smash, so it's a 1.5, 29, right? And then it gets this translation here. The translation is 3 to the right and 10 down. So 1.5, 29 becomes 3 to the right, so 3 plus 1.5, and then 29 becomes 10 down, like that. So it's going to be 4.5, 19. Okay, so the new point M, which is M prime, is 4.5, 19. Okay, and that's what they're looking for here, 4.5, 19. Okay. Now remember that we could have done this transformation to the point 3 comma 29. We could have done all that without actually drawing the pictures that I drew. Maybe that made it confusing. So you could start with 3 comma 29, and then you say, okay, I'm going to do a horizontal stretch factor of 1/2. So then you just take the x coordinate 3 and you make it half. So it's 1.5 comma 29. Then you say, I'm going to do a x or horizontal translation to the right by 3, so that becomes 4.5, and then you do a y translation down by -10, and then that becomes 19. So that's another way you could have done it. You didn't have to graph any of it, okay? But actually, that's what it looks like if it happens. Let's move on to the last part of this problem. The graph of G is the image of the graph of G is the image of the graph of F under P. Okay, so that's just like what we drew, right? Find G of T in the form G of T equals 7 times cosine B, T minus C plus D. Okay, so now they actually want us to use the, let's see. They want us to take the original function, which was f, and they want to make us do this translation, and that's what we kind of did here, right? That's what we did here. So they want to find an equation for it. Let's see. We can say let's try to find some of the characteristics of this equation. For example, the original mean line was at 22. The new mean line is shifted down by -10. So the new mean line would be at 22 minus 10. So it would be at 12, right? So the new mean line is 12. That would be D. What about A? Has A changed at all? Well, A was originally 7, and it hasn't been adjusted because we didn't do any kind of vertical stretch. So A is still 7. Let's see, what about B? B probably has changed because there was a vertical stretch by a factor of 1/2. So B should now be a little bit bigger than it was before. Before it was pi over 6. Now B is going to be b over 6 times pi over 6 times 2, because when you shrink the period, you're going to multiply b by 2. Okay? So that's actually equal to pi over 3. The only thing we don't have now is C. Now, you have to use the fact that this value m that they asked us to find the translation for, or transformation for before, this m is actually a very special point on the cosine wave, because you can see that it's the maximum point, right? And so you can see also that the coordinate of m is 3 comma 29. Remember that the original horizontal translation was 3, right? So the m value is actually, the m coordinate is actually originally the coordinate that that was at the x equals 0 point, and it's moved over 3, right? And then we have found that the m prime coordinate is going to be 4.5 comma 19, right? And so now if we know that the m coordinate was translated 3 to the right because it's 3 comma 29, well, guess what the c value is for m prime? It's been translated 4.5 to the right, okay? So we could go down here and we could put that the c value is actually 4.5, okay? 4.5. All right. Okay, give a full geometric description of the transformation that maps the graph of G to the graph of F. Now be careful, because this time they're doing a transformation from G to F, not from F to G. So remember what the transformation was from F to G? F to G was, first thing they did was they did a horizontal stretch by 1/2. And then they did a translation, positive 3, negative 10, right? Now you're going to do the opposite. First, you're going to do a translation, and you're going to do exactly the opposite translation. You're going to do negative 3, positive 10. And then after you do the translation, then you're going to do a horizontal stretch, but you're going to do it by the opposite factor times 2. Okay? So you can do the opposite. Number 2, let f of x equals sine of 2x plus 1, 0 to pi is the x value. Sketch the curve of y equals f of x on the grid below. Okay, let's see. So let's try to see some of the values for the factors in the standard form of the sine equation. And a appears to be 1, right, because there's no multiplier in front of sine. D appears to be 0 because there's no addition done after the sine. And b appears to be 2, right, because that's what's multiplied times the x. Okay. Now what about c? C appears to be 1, right? But you have to be really careful here. They're being tricky. Because remember what the standard form of sine is. It's a sine of b times x minus c plus d, right? And if you compare it to what they have here, which is sine 2x plus 1, they don't really have it in the same form as what you're expecting, right? Okay, a is 1, right? D is 0. I get that. But look, compare bx minus c to 2x plus 1. Is it in the same format? No, it's not, because look, the b is factored out, and this is not factored out, so we need to factor out the 2. Okay, so it's actually 2 times x plus 1 half. So b is 2, and actually c is actually negative 1 half. Okay, so now we have all the values. We have a equals 1, we have d equals 0, we have b equals, and it's not b equals 2, it's b equals negative, or yeah, it is b equals 2. It's not c equals, it's not c equals 1, it's c equals negative 1 half, okay? C equals negative 1 half, and b is 2. Okay, so let's see. Since b is 2, that means it's, let's see, we'll draw the regular sine wave first, okay? So we'll draw, let's see, 3.14. So normally the sine wave goes from 0 to 2 pi, and so this would be 3.14. This would be 1 pi. So it would go kind of like this, right? This is the regular sine wave, okay? And then this sine wave is has a horizontal stretch, a factor of 1 half, okay? So instead of ending at pi here, it would be at half a pi, which would be, you know, like right here. So it would be pi over 2. And so the sine wave is going to be kind of like that. Okay? So that was the horizontal stretch by a factor of 1 half. It's like the inverse, right? If instead of 2, it would be 1 half. And let's see, the c value is going to displace it by negative 1 half. Okay, so like all the points are going to move over to the left because it's negative 1 half. So it'll be like about 0.5. So we go like that, and we'll go like that, and go like that, and we go like that. So let's draw our new points. I'll draw our new points in blue. And so all my points are going to be 0.5 to the left. So I got 1 there, I got like 1 there, I got 1 there, and I got 1 about there. Okay, and then this one would be about there, 0.5. Okay. And then I draw my new sine wave there. Okay. Anything else they're asking? Find the x-coordinates of the maximum and minimum points of f of x, giving your answers correct to 1 decimal place. Okay, so they want to know the x-coordinates for this point and this point. Okay, so originally the x-coordinate was at let's see, this would be this would be pi. This would be originally was pi 3/4 pi, right? So this is actually 3/4 pi minus 0.5. Okay, because we moved over 0.5, right? And then the maximum was originally at pi over 4, and here instead of pi over 4, we're going to move over 0.5 to the left, so it's pi over 4 minus 0.5. So those are the maximum and minimums. We have pi over 4 minus 0.5, and we have 3/4 pi minus 0.5. Those are the x-coordinates for the maximum and minimum. So we can find those, some values for that. So it would be 3.14 divided by 4, 0.785 minus 0.5, and that'll give us 0.285. And then 3/4 pi would be 2.355, and then we subtract 0.5 from that, and we get 1.86. Okay, so our two x-coordinates are x equals 2.85 for the maximum, and then we have x equals 1.86 for the minimum, and those are our 2 points there. By the way, since they asked for the answers, took one decimal place, we would put 0.29, or not 0.29, but 0.3, and we would put 1.9. Okay, and that's it.